So the classified paper 6 topic chemical reactions question 3. As you can see in this one, a calcium carbonate is there, which react with dilute hydrochloric acid. The products of the reactions are aqueous calcium chloride, water, and carbon dioxide. A student investigated the rate of a reaction between calcium carbonate and hydrochloric acid using the apparatus as shown. What will be the product? As I mentioned here, calcium, so carbon dioxide gas is there. As a gas is given off, so the mass in the content of the flask will decrease. The mass of a flask and the content was recorded every 30 seconds. When the reaction stopped, there were still small piece of calcium carbonate in the flask. State what happened to the reading on the balance as the reaction take place. Explain your
It
answer.
will
Read.
decrease.
Decrease as carbon
Decrease
dioxide, the
because carbon
product
dioxide
will
escapes.
it can escape from the cotton wool.
So it will decrease. And what is the reason for that? Because the gas escape or the gas loss from the flask. Solid amount decreasing is not the right answer, because even solid amount decrease, that solid is dissolving. But what happened, that solid, when it react, it give off gas as well. And that gas escape. That's why the mass of the content in the flask decreases. So we have to explain what happened to the reading on the balance as a reaction take place. So when the reaction is taking place, the calcium carbonate react with hydrochloric acid, give calcium chloride, which will dissolve here. Water is there, and carbon dioxide is a gas which is given off. So mass will decrease, and the reason is that because the gas escape or carbon dioxide escape. You cannot mention solid dissolve, because some cases solid dissolve, but it won't change the mass until unless there will be a gas given off. When the gas is given off, that's why the mass is decreasing. If there was like a stopper is placed here, if you place a stopper, then the gas won't escape. So if the gas cannot escape, the mass won't change. Even though gas is here, given off. But if the gas does not escape, the mass won't change if we place a stopper. That's what the cotton wool is preventing the content in the mixture in the flask to preventing them to escape. Even without a cotton wool, the gas will escape, but cotton wool is preventing these content in the flask to escape. There is a piece of cotton wool in the neck of a flask. Suggest why a bung is not in the neck of a flask. Like why we did not place a bung or a
The
stopper.
gas will pressurize, the apparatus will burst.
Or you can also mention like because of the bung, as just now I mentioned, the gas will not escape, so the mass will not change. So suggest why a bung is not used uh, in the neck, so it will.
Because it's not letting the gas to escape.
Yeah, so it won't let the gas to escape, or it will prevent the gas to escape, or gas cannot escape. So the mass does not change. Suggest why cotton wool is placed in the neck of the flask rather than leaving the flask
So
open.
that the acid cannot escape from the reaction. The
Yeah,
reaction particles cannot escape.
even for example, if there was no cotton wool, if it was open, the gas will escape. But why we kept a cotton wool here? Even if there was no cotton wool, the gas will escape. So as a result, what happened? Maybe the acid, the content in the flask, like preventing or stopping the acid spray or splashing of an acid to, or due to splashing of an acid, it might lose. So you can mention here it prevent acid spray. Which reactant is in excess?
Calcium carbonate.
Calcium oxide,
Calcium
calcium
carbonate.
carbonate.
The calcium carbonate is in excess
This
because
idea is left after
yeah, it is left when the measured the reaction small pieces are left. So calcium carbonate is in excess. Then describe how crystals of calcium chloride could be obtained from a mixture. So first thing we have, like when this reaction happen or occurs, still some pieces of calcium carbonate
you
are
can
there.
heat till crisp.
No,
You can
first thing,
filter it.
To
By
remove
filtering.
calcium
Filtering it
carbonate.
is
so first we should use filter to remove unreacted calcium carbonate.
Then
we
heat
will
till point of crystallization.
Then
filter
we will
we heat
heat
it to
till the point of
crystallization point,
crystallization.
and then we leave it in a cool
Then
place to
cool
dry.
solution.
And then we dry it with filter paper to remove water of crystallization.
Then we will cool down the solution because the hot solution it won't form too much like crystallization. Solubility of a solution is higher at high
We
temperature,
need
so
to
we
heat
cool
it until it
and then we will
forms a
filter again.
supersaturated solution.
Yeah, and then we dry with the filter paper or a tissue paper. That is how it is done. So you will mention these points. Why we cool the solution? Because what happens, say you have a solution after filtration, you will have an aqueous solution of
When we
calcium
cool
chloride.
it, the solubility decreases,
Yeah.
so it
So,
crystallizes.
so we have an aqueous solution of a calcium chloride. When we supply heat energy, the amount of a liquid decrease, so it become a concentrated solution, but still the temperature is high. So as a result, when the high temperature is there, it can dissolve more. Like example, if a water which is left here, maybe the temperature of a water might be 70 or 80. So it can dissolve more calcium chloride. So what we do, we cool down the solution. When we cool down, as the temperature start to decrease, the solubility, it cannot adjust too many salt particles or ions in the same space. So as a result, these salt crystals form or crystallization happen or occur. And these crystals we separate by filtration. So the main purpose of cooling down a solution is to reduce the solubility so that we can obtain maximum amount of salt from it. Yeah, in crystallization we don't get all of a salt. Still some of the salt is still dissolved at 30 degrees. We don't get full salt from it. So this was a question from the chemical reaction, question 3.